Today's notes are over a composition of functions. The first thing I want to do is review function notation. Recall how we evaluate functions in function notation. We can substitute any real number for x in a function. For example, if f of x equals 3x minus 2, if I write f of 4, that's how I would say that, f of 4, I'm replacing x with 4 in my notation when I write f of x, which recall that f of x is just fancy schmancy for y. That just means y. And that's our output, right? F of x is our output. So f of 4 means I'm going to replace x in my function with 4. When I replace it with 4, I can then evaluate it. 3 times 4 is 12. 12 minus 2 is 10. Therefore, f of 4 equals 10. That just means when I plug in 4 for x, I get 10 for y. Function composition is a way to combine functions. The process is the same, but we will replace x with an entire function. This means when we compose functions, we are using the output of one function, which is y, as the input of another function, f. Now I know that can be kind of tricky to understand, so let's just walk through it. So the first thing that I want to show you is the notation, like how it's written. This right here, where you have f of, and then you have an open dot, g, and then that's in parentheses, and then you have an x. That is read as f of g of x. You can also write it this way, f of g of x. Or you might see it like this, where you've got brackets, f of g of x. Either way you see it, any way that you see it, right? This first way right here, this way, or this way, it all would be read as f of g of x. Where you have your outside function, which is f of x, that's right here, and your inside function, which is g of x right here. If you think about your function notation that we wrote at the top, I'm replacing x, so instead of f of x, what am I replacing x with? I'm replacing it with, rather than a real value, a real number in this situation, I'm replacing it with a function, which is g of x. So what I'm going to do is I'm going to put g of x inside of f of x. That's how I'm going to combine those functions. When we talk about the output of one function being the input of another function, hear me out on this. If f of x or g of x, right, if that's just fancy schmancy for y, then when I put that g of x, right, inside of f of x, that means the y value for g of x, I'm using as the x value for f of x. Okay, I know that's kind of tricky to understand, so I'm just going to get started on the process. What do you do to compose functions? So in this first example, let f of x equals 2x plus 5, g of x equals 3x minus 8. I just have two linear functions here, and I'm going to compose them. So this says to find the function rule for f of g of x. So f of x is our outside function, and g of x is our inside function. What I want you to do is first write the outside function. So when I write the outside function, I'm going to write 2x plus 5. That's what I did first. Okay, and I'm going to actually change colors here, so when we walk through it, hopefully it makes a little more sense. Then the second step says to replace x with a set of parentheses. So instead of 2x plus 5, I'm going to do 2, open parentheses, plus 5. Then step 3 says to write the inside function inside the parentheses. So I'm going to replace x with parentheses, and then inside those parentheses, I'm going to put 3x minus 8. So I'm replacing x with g of x. I'm putting the inside function in the outside function. And then we're going to use the order of operations to simplify. So I'm just going to distribute this 2 into every term inside the parentheses. So I'm going to get 6x minus 16 plus 5. And then when I combine like terms, I'm going to do negative 16 plus 5 to get negative 11. So I get 6x minus 11, which represents f of g of x. That is our composed function. So let's move on to this first set of examples. These are our linear function composition examples. They're exactly like the ones that we just did. So I've got three functions at the top up here. I've got f of x equals 2x plus 3, g of x equals 4x minus 5, and h of x equals 1/2 x plus 4. Example number 1 says find the composite function f of g of x. So when I first look at this, I notice f of x is the outside function, g of x is the inside function. So what I'm going to do is follow the process that I just showed you. And I'm going to write the outside function first, 2x plus 3. And then the second step, I'm going to replace x with a set of parentheses. Anywhere you see x, replace it with a set of parentheses. If you were evaluating functions, like what you did in Algebra 1 and what you probably reviewed at the beginning of the year, I would do the same process, but instead of in the parentheses, I would put an actual value, a real number, any real number, 2, negative 3, okay? In this case, we're putting the entire function, so I'm going to put g of x inside those parentheses, which is 4x minus 5. And now we're going to simplify using the order of operations. So I'm going to distribute this 2 into every term, so I get 8x minus 10 plus 3. And now I'm going to combine like terms. Negative 10 and positive 3 is negative 7. So I get 8x minus 7, and that represents f of g of x. Now, I also want to show you just a way that you might see it written. So I tend to teach it this way just because that seems to be the way that my students have understood it better, right? Write the outside function first, put the inside function in the outside function, okay? But you could think about it this way. If I'm composing f of g of x, then I want to find f of 4x minus 5. In this case, I've written the inside function first, right? And this is just my way of notating that I'm putting this function, I'm replacing anywhere I see x, I'm going to replace it with 4x minus 5. Then, you know, by doing this, I'm showing you that g of x is the input of f of x using this notation. So this is just a way of notating it. So then you might say, okay, now then, f of 4x minus 5 equals 2 times 4x minus 5 plus 3. So you just might see it written that way. Or that's like the process. Like if I'm solving this, if I'm teaching, you know, pre-cal, I might be writing it that way, you know, first. This is just a first time that you've seen composition of functions. So let's move on to example number 2. Find the composite function h of f of x. Using the process that I stated, we're going to write the outside function first, which is h of x, which is 1/2 x plus 4. Then I'm going to replace the x value, or the x, with parentheses. So 1/2, I'm replacing x with parentheses. What am I going to replace x with? I'm going to replace it with the inside function, which is f of x, and that's 2x plus 3. And now we're going to simplify using the order of operations. So I'm going to distribute that 1/2, and I get 1x, so just x. 1/2 times 3 is 1.5, so plus 1.5, and then plus 4. And now I'm going to combine like terms. 1.5 plus 4 is 5.5. So x plus 5.5 represents h of f of x. So let's move on to example number 3, and I'm going to write the functions first, and then I'll zoom in so you can really see that. So in example number 3, it says find the composite function, and I have it written this way just because you may see it written this way, okay? This means the same thing. This g of f of x, this means the same thing, and let's write that down. This means the same as g of f of x. That means the same thing. So let's start with writing our outside function, which is 4x minus 5. G of x equals 4x minus 5. Then what do? We replace x with parentheses. And inside those parentheses, I put the inside function, which is 2x plus 3. Okay, now I'm going to zoom in. And now we can simplify this using our order of operations. I'm going to distribute that 4, and I get 8x plus 12 minus 5. And then I'm going to combine like terms. 12 minus 5 is 7. So I get 8x minus 7, and I'm writing a function. And the composed function is, let's write it this way, just because it was shown this way, g of f of x. Okay, and it's not a closed dot, it's just an open dot, g of f of x. That does not mean multiply, it means composition of functions. So let's move on to some additional function composition examples, and the next 3 examples, deal with some linear functions and some quadratic functions. So in these next examples, make sure that you remember how to multiply binomials. In example number 4, it says to find the function rule for h of g of x. So the first thing I'm going to do is write the outside function, which is h of x, and that's x squared minus 4x plus 2. G of x is my inside function. That's a linear function right here, okay, in orange. I'm going to replace anywhere I see x with g of x. Notice that I see x right here and right here. So I'm going to replace x with g of x. But remember, whenever you're evaluating these functions like this, you're going to replace only the x value with whatever you're replacing x with. So if I'm squaring x, I'm going to square that entire thing, right? So don't forget that exponent. Minus 4 times x plus 2. And now I'm going to put my inside function in there. And I'll use a different color here so you can really see it. I'm going to put 3x plus 1 in there. Now in this first little part, 3x plus 1 squared, like when I'm simplifying this, I'm going to need to multiply 3x plus 1 times 3x plus 1, because that's 3x plus 1 squared, right? Multiplying it by itself. When I do this, I get 9x squared, and then I get 3x plus 3x, so that's plus 6x, then plus 1. And I'll switch back to purple here. So when I'm simplifying this, I get 9x squared plus 6x plus 1. And now I'm going to go ahead and distribute this 4, negative 4, into each term inside the parentheses. So I get minus 12x, minus 4, then plus 2. And now I'm going to combine like terms. And I'm going to write this in standard form, right? So highest exponent first. I have 9x squared. And then I'm going to combine 6x with negative 12x to get negative 6x. And then I have positive 1, negative 4, that's negative 3. And positive 2 is negative 1. And that is the function h of g of x. That's the composed function, h of g of x. And there's the function. Let's move on to example number 5. And again, this is written a different way, but it means the same thing, right? F of g of x. And if you want to, f of g of x, if that helps you, go ahead and write that down. F of g of x. So what are we going to do? Let's write that outside function first. And remember, you also might see people work this out. F of g of x, okay, that's going to be f of 3x plus 1, right? Because that's g. So f of g of x. F of x is 2x squared plus 3. And I'm going to replace x with parentheses. Don't forget to square it. Okay, what am I replacing x with? I'm replacing it with g of x, which is 3x plus 1. And again, 3x plus 1 squared, I'm going to have to do that, right? Using my order of operations, 3x plus 1 squared is what I'm going to do first when I'm simplifying this, and that's right up here, which is 9x squared plus 6x plus 1. So let's write this out. 2 times 3x plus 1 squared is 2 times 9x squared plus 6x plus 1, then plus 3. And now I'm going to distribute this 2 to each term inside the parentheses. So I get 18x squared plus 12x plus 2 plus 3. And now I'm going to combine like terms, which is 2 plus 3, and I get 5. So 18x squared plus 12x plus 5 is the composed function f of g of x, and that's an open dot, okay? F of g of x. Let's move on to our final example for this portion, which is the composite function h of f of x. So again, I'm going to do this and then I'll zoom in once I get my functions in there. So let's change colors here. H of f of x. So the first thing I'm going to do is write the outside function, which is x squared minus 4x plus 2. So x squared minus 4x plus 2. And then I'm going to replace those x's, the variable, with parentheses. So x squared minus 4 times x plus 2. And then inside those parentheses, I'm going to put the inside function, which is f of x, which is 2x squared plus 3. That's 2x squared plus 3. 2x squared plus 3. Okay, so now I'm going to zoom in, and let's do this. So whenever I'm simplifying this using the order of operations, the first thing I need to do is square this binomial, 2x squared plus 3. So I'm going to do that off to the side. 2x squared plus 3 times 2x squared plus 3. And if I FOIL this, I get 4x to the 4th. And then I've got 6x squared plus 6x squared, which is 12x squared. And then 3 times 3 is 9. So now let's write this out. 2x squared plus 3 squared is 4x to the 4th plus 12x squared plus 9. And then let's go ahead and distribute this negative 4 into each term inside the parentheses. So that's negative 8x squared minus 12, then plus 2. And now we're just going to combine like terms here. And I'm going to start with my highest exponent first because we're going to write it in standard form. That's 4x to the 4th. And then I've got 12x squared, negative 8x squared. That combines to positive 4x squared. And then I've got positive 9 and negative 12 and positive 2 all combine to negative 1. And that represents the composed function h of f of x. So let's move on to the very last portion of today's lesson, and that's finding a specific value in a composed function. And I'm setting this differently, like I'm teaching this at the end because when I've taught it kind of like intertwined in my lesson, students tend to get confused with the process, okay? So when you're finding a specific value in a composed function, you're just evaluating that composed function for the value that is the initial input, right? The number that you see. Okay, so let's get started. As previously mentioned, when we compose functions, we are using the output of one function, y, as the input of another function, x. So I've got these two functions here. Looks like Christmas. F of x equals 5x plus 1, g of x equals 3x minus 7. So suppose you were looking to find f of g of 4. I'm going to walk you through this. Well, let's first find g of 4. G of 4 in this function up here, if g of x equals 3x minus 7, then g of 4 equals 3 times 4, which is 12, minus 7, which is 5. G of 4 equals 5. What we're going to do is we're going to take the output of that function and use it as the input of the other function. So now we're looking for f of 5. F of 5 is 5 times 5 plus 1, which is 25 plus 1. F of 5 is 26, which means f of g of 4 equals 26. So let's look at, and let's make a little note here. I want you to, so, when you're doing your problems, you can come back. Evaluate the inner function first. Evaluate the inner function first, then use the output value to evaluate the outer function. Use the output value to evaluate the outer function. So we're going to use the same process to determine the following. Number 7 says f of g of negative 2. So the first thing that we're going to do is find g of negative 2. What is g of negative 2? G of negative 2, and I'm going to write this out, is 3 times negative 2 minus 7. 3 times negative 2 is negative 6. Negative 6 minus 7 is negative 13. Therefore, g of negative 2 is negative 13. Now we want to find f of negative 13, right? If g of negative 2 is negative 13, then now we're looking for f of negative 13. F of negative 13 means 5 times negative 13 plus 1. I'm sorry. Yes, 5 times negative 13 plus 1, which is negative 64. Which means f of g of, and I'll write this down, negative 64. F of g of negative 2 equals negative 64. So when we're evaluating for a specific value in a composed function, we're just going to get a number as our answer. Okay, and that's a big difference. And I've had students that really struggle with, okay, when are we doing this? And when do we get that? Whenever you're evaluating and there's a number in there, you're going to have a number as your answer. Let's look at number 8. Number 8 says g of f of 1/5. The first thing we're going to do is find f of 1/5. F of 1/5 is, f of 1/5, I'm going to write it like that, is going to be 5 times 1/5 plus 1. 5 times 1/5 is 1, and 1 plus 1 is 2. So f of 1/5 equals 2. Now, if f of 1/5 is 2, we're now finding g of 2. We're going to use the output of that function as the input of the next function. So g of 2 is going to be 3 times 2 minus 7, and that is 6 minus 7, which is negative 1. So g of f of 1/5 is negative 1, and that's our answer. Let's move on to g of f of negative 3. And remember, I've just written it like this because sometimes you might see it like this. It still means g of f of negative 3. Okay, if you want to write that down, g of f of negative 3, you can write it that way, whatever helps. So the first thing we're going to do is find the value of that inner function, f of negative 3. So f of negative 3 is 5 times negative 3 plus 1, which is negative 15 plus 1, that's negative 14. So f of negative 3 is negative 14. Now we're going to evaluate that outer function, which is g. We're finding g of negative 14, right? If f of negative 3 is negative 14, we're now looking for g of negative 14. So 3 times negative 14 minus 7, that's going to be negative 49, which means g of f of negative 3 is negative 49. The very last problem that we're going to do, and hopefully this helps you kind of tie some of this together, is it says find the function rule for g of f of g of f of x. Then we're going to use the composed function to find g of f of negative 3. So we're doing the same thing that we did on 7, 8, and 9, but I just want you to go about kind of combining basically what we did on the first 6 examples and what we're doing on this page. So if I find the composed function, I can always, g of f of negative 3, that's what I did up here for number 9, right? I found g of f of negative 3. I already know the value of it. But what I want you to see is that if we find the composed function, g of f of x, right? That's just g of f of x, using the process that we did previously. Let's go ahead and do that. So I'm going to write that outer function, which is g of x. That's 3x minus 7. And replace x with parentheses. What am I going to put inside the parentheses? I'm going to put f of x, which is 5x plus 1. Okay, now I'm going to zoom in, and I'm going to simplify this. So 3 times 5x is 15x. 3 times 1 is plus 3, minus 7. When I combine like terms, I get 3 plus 3 and negative 7 combined to make negative 4. So that's 15x minus 4. And this represents the composed function g of f of x. So this is the function we will use now if we're evaluating g of f of negative 3. We can do what we did on 7, 8, and 9, right? That was kind of like conceptual. But if I'm looking for g of f of negative 3, I can find g of f of negative 3. If this is the function, I'm going to replace x with negative 3 here. Oh, not equals, sorry. Minus 4. And 15 times negative 3 minus 4 is negative 49. And as you can see, that is the same as up here, right? So this is the same as number 9. We get the same answer, all right? But I wanted to kind of tie those two things together. So that concludes your day 1 notes over composition of functions. All we did were linear and quadratic functions. So I hope that was helpful.